everybody. It's Miss Smith. So today we're going to talk about covalent naming. Now, if you ever hear me say molecular naming or molecular compounds, molecular bonds, it's the same thing as covalent. Covalent bonds, covalent compounds, covalent naming, it's all the same. Now, everything that we have done up until this point is actually called ionic naming, ionic compounds. And those are the ones that use a metal and a nonmetal. So, and covalent is all nonmetals. So I'll give you a visual in here in a minute that tells you the difference. But anyway, knowing the difference between ionic and covalent is going to make or break this big quiz that you've got next week. Because next week I'm going to give you a quiz over everything that we have done. You're going to put everything together that I have taught you. We're taking a big old quiz next week. So, but knowing the difference between ionic and covalent is going to make or break your grade on this. So please make sure that you at least get that today. All right, let's go into our notebook. All right, so I actually made this video earlier today, and it didn't record the audio, so that's why my notes are already here. So I'm not going to waste any time with me writing these in. I'll just kind of go over them. But let's go into the different types of bonds. So everything that we have done up until this point is called an ionic bond. That's when you have a metal and a nonmetal together. So let's talk about metals and nonmetals for a minute. So on the periodic table, there is a stair step that looks like this. Anything to the right side of this stair step, so that's going to be anything here, anything to the right side of the stair step is considered a nonmetal. Except for hydrogen. Hydrogen is also a nonmetal. That's the exception. Anything to the right, the left side of the periodic table, left side of the stair step is called a metal. Now, most of the periodic table are metals. All right, now, so remember that hydrogen is that exception. Let me go ahead and draw the stair step back in here. All right, so that's an ionic bond, is when you have a metal and a nonmetal. When you have two or more nonmetals, that's a covalent bond. And the rules for covalent bonds or covalent compounds are very different than ionic bonds. Everything that we have done up until this point is for ionic compounds. Covalent compounds are very simple. Now, there is a third type, and that is called metallic bonds or metallic compounds. And so those are going to be something like iron and nickel, which I think makes stainless steel, or copper and iron, which I think is bronze. I could be very wrong about that. But anyway, it's when you put several metals together and they create what's called an alloy. And so that's when you put several metal ions together. They actually have their own properties and things. They're very, very different. They're malleable and they have ductility, and there's all these different things. You can hit it with a hammer, you can draw it in wires, but those are properties of metallic compounds. Now, you're not going to be asked to name those, so don't worry about that. Now, let's go into this real quick. Let me erase some of these things. Forget what you're seeing. Sorry about this. I should have erased before I started recording. I forgot. Okay, anyway. So here are a couple of examples. And so I want to talk about which ones are ionic and which ones are covalent. So just take a second and pause the video, and I want you to take a guess. Which ones are ionic and which ones are covalent? None of these are metallic. They're all either ionic or covalent, so take a guess. All right, so on this first one, lithium is on the left side of the periodic table. Lithium is here, and then carbon and nitrogen are both over here on this side. So because they're on opposite sides of the periodic table, that means that it's ionic. All right. The next one, carbon and oxygen, they are both over here. So that means they're both nonmetals, which means that is covalent. The next one, potassium and, not potassium, phosphorus and fluorine. Those are both over here. Those are both on the right side of the stair step, so that's also covalent. And then we've got lead, sulfur, and oxygen. Now lead is here. Oh, where is lead? Here's lead. That still is on the left side of the stair step, so that means that's a metal. And then we have sulfur and oxygen. They're technically on opposite sides of the stair step, so that means that they are covalent. Ionic, not covalent. Ionic. All right, moving on. So this one says how to name covalent compounds. Now, so the first step is to find the name of the first term and apply a prefix if needed. So something I also forgot to mention was that on the first term, it's going to keep its real name. So none of this, the first term is not going to have an IDE ending. It's going to keep its real name, so the original name. Now what you're looking at on the periodic table, the one that we've been working with over the last week, is the periodic table of ions. So this is a regular periodic table where the negative ones have not been renamed to IDE. So for example, phosphorus would not be phosphide like you see on your periodic table of ions. It would be phosphorus. But that's only on the first term. Now on the second term, so it says find the name of the second term. Okay, this will then give it an IDE ending. And then you apply your prefix as needed. Okay, now the only other thing that you really need to talk about are and then the third step is just to write it all down. So the only thing that you really need to know is the prefixes. So let's go into the prefixes. There are 10 of them. So 1 is mono, and that is only with oxygen. 2 is di, 3 is tri, 4 is tetra. If you're not writing these down, please write these down. You are going to need them. Okay, write them down somewhere. If you need to write them down in your periodic table, do it. Okay, so you don't have to keep going back and forth to your notes. Write it on your periodic table. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. 10 is deca. Okay. Now, sometimes you don't always put the A at the end because a lot of these prefixes end in A. Sometimes you put it, sometimes you don't. Like if I was going to use it, if I had like 5 oxygens, I wouldn't say pentaoxide. I would just say pentoxide. Okay, it's really whatever just sounds better. I'm not taking off her spelling. It's fine. I'm just happy at the fact that you said pent and oxide. I'm happy at that, so I'll take it. All right, let's do a couple of examples. Okay, so the first example is SO3. Okay, so the first thing is I find the name of the first term. Now remember, the first term keeps its real name, so that is sulfur. Now, I don't have a prefix here. There's no prefix here. Okay, if I had a number there, then I would have to put a number up front because prefixes go in the front. But I don't, so that means that's actually a 1 there. It's an understood 1, but I only use mono with oxygen. So that's just going to say sulfur. Now the next term is oxygen, but remember the second term gets an IDE ending, so that is oxide. And I do have a prefix here, so that's 3, so that's tri. That's going to be trioxide. Let's try another one. Okay, Cl2O7. So this one here, this is the first term. It keeps its real name. It does have a prefix, so that's going to be dichlorine. See here that I don't have ide because it's the first term. I don't have IDE. It's not dichloride. It's dichlorine. The 7 is hepta. That does get an IED ending. So hepta oxide. I mean, that A in there looks a little weird, but I'll take it. So heptaoxide. Okay, another example would be P4O10. Now this one's crazy. There's a lot on here. Okay, so P is going to be phosphorus, not phosphide. It does have a prefix, and 4 is tetra. So tetraphosphorus, and then this is oxide, and the 10 is dec. You could say decaoxide. You could leave the A off if you wanted to between the C and the O. So you could say decoxide or decoxide, either one is fine. Okay, so those are 3 examples. So let's do one where you try it on your own. Let's do this one here. Nope, we did that one already. I think we did that already. Did we do it already? I did. I talked about it, but let's go ahead and let's name it. So try this one. Go ahead and try to name it. Just pause this video real quick and try to name it. Okay, so this one, there's no prefix here, there's no prefix here. It is covalent, so I'm going to use my prefixes, but there's no prefix here, there's no prefix here. So those are understood to be ones. Now, on carbon, I'm not going to write mono, because remember, the only time you use the prefix mono is with oxygen. So the name of this is carbon monoxide. Okay, so the next one is how to write the formula of covalent compounds. Okay, step 1, find the symbol of first term, apply prefix number if needed. Step 2, find the symbol of second term, apply prefix number if needed. Okay, and then third step is to write it all down. Okay, so the prefixes are the same, so I'm not going to write these down again. But let's go into a couple of examples. Let's say that you have nitrogen trichloride. So what everybody does here is they try to write, let me do this wrong first. This is what everybody tries to do because it says nitrogen trichloride, just like the name says. No. Okay, that's not the answer. That's not how you do that. The number, the prefix goes after. So it's going to be NCl3. It's after. The prefix goes after what it's attached to. So let's try another one. Dinitrogen pentasulfide. Okay, so that's going to be dinitrogen. So that's N2. Pentasulfide, that's 5. So S5. Okay, so let's do one of these where you try on your own. So I want you to try silicon tetrabromide. Okay, so pause the video and try this one. All right, so the answer for this one, there is no prefix here, so that's just Si, no number after that. And then bromide is Br with a 4 after it, and that's it. Okay, hopefully you understood all of this, hopefully. There are a couple of slides that I want to look at just real quick before we get out of here. Let me pull this up. It may take me a minute. Where is Google Drive? There's Google Drive. Okay, so a couple of these I wanted to go through just real quick, so that way, actually, you know, just us working this together will help you out, and then also, just I'm sure there's a couple of these that we don't really need to do, like this one, for example, this first one, this says metals, it says electrons are exchanged in an ionic bond, metals blank valence electrons to form cations. Okay, I'm not worried about that. I really should have taken that off of there. In a covalent or molecular bond, valence electrons are shared between more nonmetals, not exchanged. So really I should have taken that slide off of there, but I didn't. So oops. Anyway, so I'm not really worried about slide 3. Y'all can skip it if you want. I'm not worried about valence electrons right now. That comes later. So, on this one, so the answer says, the question says, which bond, this one here, I want to talk about the top left, which bond is it going to be? This is going to be, because both of them are nonmetals, both of these are going to be, that is going to be covalent since both of them are nonmetals. This one, they're on opposite sides of the periodic table. That is going to be ionic. Oh, I'm messing stuff up here. That's ionic. And then this one, they're still on opposite sides of the stair step, so that one is also ionic. Okay, next. Okay, ionic versus covalent. Now, some of these are going to be similar. So, two nonmetals, that is covalent for sure. Okay, metal and a nonmetal, that is ionic for sure. May need Roman numerals, that is only for ionic. You only ever need Roman numerals with ionic. Names uses prefixes like mono or tetra, that is only for covalent. Second element is a nonmetal. Now, that could be both of them, because on ionic, your second one is always a nonmetal, and then covalent, the second one is always a nonmetal. So that's both. Reduce charges when writing formulas. That is only with ionic. You don't do that on covalent. Have high subscripts like 8 or 10. That is only for covalent. You never really have them. Well, no, that's only going to be covalent. So I'm trying to think of a scenario where you would have a prefix at high. Or not a prefix, a subscript at high. Second word can end in IDE. That is both of them. First word doesn't have mono. That's both of them, yeah. Second word can end in ate or ite. That is only ionic. Okay. Now on the next one, which bond will each pair of elements form? So sodium and oxygen. Sodium's on the left side of the left side of the stair step. Oxygen's on the right. So that is ionic. Nitrogen and oxygen. Those are both on the right side of the periodic table. So that's covalent. Hydrogen and sulfur. Okay, this is the exception. Yes, I know that hydrogen is on the left side of the periodic table, but remember, hydrogen's the only one over there on the left that is a nonmetal. So technically that's covalent. And then lead and oxygen, lead is for sure a metal, and that's on opposite sides of the stair step. So that's ionic. All right, this one here. I'll let you do this one on your own. Just remember you need to circle ionic versus covalent. Okay, and that's it. All we're going to do today. If you need any help, let me know. You know where to find me.